So, what if I told you? Everything you think you know about how the world works is about to be turned completely upside down. We're all used to the basics, right? Metal is strong, liquids are wet, black is, well, black. What if a material looked like a cloud but you could hold it? What if a liquid could be sculpted with magnets? What if a metal melted in the palm of your hand? These aren't sci-fi. They are real mind-bending materials. We're exploring the 15 weirdest materials. Let's get into it. All right, first up is a material that genuinely messes with my brain every time I see it. This is aerogel. It's known as the world's lightest solid material. Just look at it. It looks like a piece of frozen smoke, or a ghost you can hold in your hand. It's made by taking the liquid component out of a gel, then replacing that liquid with gas. What you're left with is over 99.8% air. Despite being mostly air, its nanostructure makes it an incredible insulator. You can hold a blowtorch to one side and it will barely get warm on the other. NASA used it on Mars rovers. Okay, now for something that feels like it's straight out of a superhero movie. This black puddle right here is called ferrofluid. At first glance, it looks like oil, but introduce a magnet and the liquid comes alive, forming intricate spikes that follow magnetic field lines perfectly. It's packed with nanoscale magnetic particles suspended in a carrier fluid. Each particle is coated with a surfactant to stop clumping, so it stays liquid while reacting intensely to magnetic fields. It's used in high-end speaker dampers and as liquid seals in hard drives. But honestly, the coolest thing is just playing with it, like commanding a real-life venom symbiote. All right, check this out. I'm holding a solid piece of metal. It looks like aluminum. It's hard, it's shiny, but it has a secret. This is gallium. Its melting point is just 85.6 degrees Fahrenheit, 29.8 Celsius. My hand is warmer than that. Hold it a moment. Look at that. It's literally melting into a silvery puddle right in my hand. It's a purely physical change, like ice melting, but it's a metal. Pour it in a mold, cool it, and it's solid again. One weird side effect is liquid metal embrittlement. Scratch an aluminum can, rub gallium on it, and the can becomes incredibly brittle. You can tear it apart with your hands. Look at this object. What shape is it? It's hard to tell, just a flat black void. It's actually crumpled aluminum foil, coated in Vantablack. Not a paint, but vertically aligned carbon nanotubes, a forest that traps light until it's absorbed as heat. It can absorb up to 99.965% of visible light. A normal black paint might absorb 95%, but that extra few percent erases texture and depth, making 3D objects look like flat black holes. It's used in telescopes to reduce stray light, and the visual effect feels like a glitch in reality. I have a paper clip made from nitinol, also known as memory metal. I'll bend it, twist it, turn it into a tangled mess. It looks ruined, right? But this metal has a secret memory. Apply a little heat, dip it in hot water, and look at that. It snaps back to its original shape. It switches from a soft, deformable martensite phase to its trained austenite phase when heated, a phase transition in its crystal structure. From self-expanding medical stents to nearly unbreakable eyeglass frames, shape memory changes everything. Pour water on sand, you get wet sand. But this isn't typical beach sand. This is hydrophobic sand, magic sand. Watch. Water beads and rolls right off, leaving the sand completely dry underneath. It absolutely refuses to get wet. Pour it into water and it forms silvery blobs and tunnels to avoid contact like alien coral. Scoop it out, bone dry. Each grain wears a microscopic hydrophobic coating that repels water. Originally for oil spill cleanup, now a brain-breaking science toy. Remember transparent aluminum from Star Trek? Meet Elan, aluminum oxynitride. Looks and feels like glass. It's a ceramic about 3 times stronger than steel of the same thickness and can stop a .50 caliber armor-piercing bullet, while staying optically clear. Made by high-temperature molding and precision polishing, it's pricey, but thinner and lighter for the same protection. You'll find it in armored windows, drone optics, and missile domes. Science catching up to imagination. This next material is so extreme, we can't even hold it. One of the rarest, most sought-after substances, metallic hydrogen. Hydrogen is a gas, the lightest element. Squeeze it under unimaginable pressure more than at Earth's center, and electrons delocalize like a metal. In 2017, Harvard scientists claimed to create it by crushing hydrogen between diamond anvils for a fleeting moment. It could be a room-temperature superconductor, zero resistance, revolutionizing energy grids, supercomputers, maglev, and even ultra-powerful rocket propellants to reach Mars faster. We've seen lab and deep Earth materials. This one is alive, a colony of bioluminescent bacteria. Species like Vibrio fischeri produce light via a reaction involving luciferin and the enzyme luciferase. Through quorum sensing, they glow together only when enough are present, painting oceans with milky seas. Scientists are exploring self-illuminating trees and medical biosensors that glow in the presence of specific toxins. This tub holds cornstarch and water, a non-Newtonian fluid. Move slowly, it's liquid. Hit it hard, it becomes solid. You can run across it without sinking until you stop. Under sudden pressure, suspended particles jam, creating a temporary solid, shear thickening. That paradox powers flexible body armor that stays soft until impact. Remember aerogel? This is its crazier cousin, aerographite, officially the lightest material on the planet. It's 6 times less dense than air. Let air in a vacuum chamber and a piece can float upward. A 3D mesh of hollow carbon tubes, almost empty space, yet compressible, springy, conductive, and super hydrophobic. Grown on a zinc oxide scaffold coated via CVD, then etched away, promising ultralight batteries and pollutant filters. Shungite, an almost 2 billion-year-old carbon-rich mineraloid found in Karelia, Russia, has undeniably strange properties. It contains trace fullerenes, Nobel-celebrated carbon cages. Locals used it to purify water. Studies show antibacterial effects and contaminant reduction. Many say shungite can absorb and shield EMF from routers and phones. Scientists are still debating how strong these effects are. An ancient rock with a unique molecular makeup and unusual properties we're only beginning to understand. Tungsten carbide, a tungsten carbon compound, one of the hardest materials on Earth. On the Mohs scale, diamond is 10. Tungsten carbide is about 9 to 9.5, dense, with a melting point over 5,000 degrees Fahrenheit. It's the go-to for cutting, drilling, and withstanding massive abrasion. Drill tips, industrial machinery, even penetrators. In jewelry, it's virtually unscratchable in daily life. Scrape concrete, steel, or granite, and it still looks new. You can't float magnets stably, Earnshaw's theorem. But this material lets us cheat. Pyrolytic graphite. It's strongly diamagnetic. It repels magnetic fields. Arrange 4 magnets with alternating poles. Place the graphite above, and it floats stably, no strings attached. Gently poke it, and it wobbles, then restabilizes. No power, no cooling. Just physics and weird quantum properties. For our last material, back to basics. Obsidian, a volcanic glass forged when lava cools so fast crystals can't form. Used for millennia for tools and weapons because it fractures into phenomenally sharp edges. An obsidian edge can be just a few nanometers thick, essentially a molecule wide, sharper than surgical steel. Some surgeons use obsidian blades for cleaner cuts that cause less tissue damage and scarring. Nature's own scalpel. So there you have it, 15 materials that totally challenge our ideas of what's possible. Which one of these materials completely blew your mind? I'd love to hear about it in the comments below. From frozen smoke and liquid magnets to metals that melt in your hand and rocks that can levitate, these are the building blocks of the future. If you had fun nerding out today, hit subscribe and ring the bell. Thanks for watching. See you in the next video.